so each of these we're going to be looking at is we're trying to figure out what was the mistake that was made. So for this one here, we want to only sell the ones that are within 1 standard deviation of the mean. So that means we need to know what the mean is, which we look at here. So we look carefully at what has been done, and we find out that this is our first mistake here. This was supposed to be 208. So we'll go ahead and fix that and see what it really changes. So 184 plus 146 plus 223, oopsies, plus 195 plus 177 plus 208. And then we divide that by 6. There are 6 of them. 1, 2, 3, 4, 5, 6. Which is 188.83. We're going to go ahead and just round it up to 189 anyhow, because we really don't need to have a perfect number here, and using this number and these numbers here will help us get that. So the first thing that I need to do is to find out how far away these are. So that is 5 away. So again, this number is 5 away from the mean. This is 43 away. This is 34 away. This is 6 away. This is 12 away. And that is not 20. So what, 208 minus 189 is 19 away. So we need to go ahead and fix that. So we have what, 25 squared. I'm sorry, no. 5 squared plus 43 squared plus 34 squared plus 6 squared plus 12 squared plus 19 squared. So we double check those are all the right numbers. Good. And I do want to divide by 6. So that gives me 595. But the thing that's not on here is this square root. We were supposed to square root that. So that gives us 24.39. And again, you want to just kind of think about this. This number is supposed to say what's the average distance these guys are from this. None of these are this. Each of these, then, I mean, the answer has to be between 5 and 43. And so now it is between 5 and 43. Now that's not our answer. That is 1 standard deviation. So if we look at our little chart here, this is my 189. And then if I add the 24 to it, this is 213. And if I subtract the 24 from it, I get 164.61. So we're saying only the pigs that lie in between these two numbers are going to be okay. So that's over here too far, this is over there too far. Everything else is in there. So A and D and E and F will be the ones that are selected. All right, let's go ahead and try, whoops, I meant to try number 2 next. So here's number 2. So for this one here, we are looking at times. And when you're talking about times, is it good to have a short time or a long time for an event? Because I think we want to have short times for the event in order to win, right? So what I need to do is each of these here have different standard deviations. So what I need to do is figure out the z-score so I can compare them all. Because right now, I don't know which is better comparatively. So I need to find my z-scores. And this is the first part of finding my z-score, where we do our x minus our x bar over the standard deviation, where this is your score or time or whatever. This is the average, and then this is the mean. So this is the first part, but what I was supposed to do is then divide by the standard deviation. And when I do that, I get 1.45. The next one, same thing. I need to divide by our standard deviation, which gives us 0.79. And then our last one, we also need to divide by our standard deviation, which gives us 1.06. So if I'm looking at my chart, here is the mean for all of them. Here is the standard deviation away. So 1.4 is right here, so that is like for our swim. And 1.06 is like right here, so that is for our running. And then 0.79 is about right here, so that is our biking. Now, as you go farther and farther this way, these are slower and slower runners. These are people who are taking longer to complete the race. These are people who are finishing faster. So it's actually good to have your score closer to this way as you possibly can. In fact, a negative z-score would be awesome, because then that means that we're faster than the rest of all of these people. But comparatively between these three, the biker is the fastest comparatively. All right.